All right, welcome back to another episode of Math with Mr. Young. So today we're going to work on lesson 8.6, Polygons in a Coordinate Plane. Our standard is 6th grade number since C, and our objective is that we're going to be able to draw polygons in a coordinate plane and find distances between points in a coordinate plane. Our mathematical literacy, we have coordinate plane, polygon, vertice, edge, face, origin, quadrant, and the y and x axes. Alright, with lesson 8.6, we're going to work with polygons on the coordinate plane. Our success criteria is that we're going to be able to draw polygons on the coordinate plane and also find distances between points on the coordinate plane with the same x coordinates or the same y coordinates. We're also going to be able to find horizontal and vertical side lengths of polygons in the coordinate plane. And lastly, draw polygons in the coordinate plane to solve real-life problems. Alright, for our mathematical literacy, we have the x-axis, the y-axis. Now remember that the x-axis is your horizontal number line, alright, side to side, okay? And the y-axis is the vertical number line, up and down. The origin is the beginning point, and that's where we always begin. In a coordinate plane, this is a flat surface formed by the intersection of two lines or axes. The horizontal number line known as the x-axis and the vertical number line known as the y-axis. All right, and the x and y axes, when they intersect right here, when they intersect where they cross at the origin, the beginning. We always start right here, okay? And this coordinate plane, it's broken down and divided into 4 quadrants, and they go counterclockwise. Counterclockwise is opposite of clockwise. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Alright, with the coordinate plane, your y-axis is your vertical number line, your x-axis is your horizontal number line, side to side. Now remember, with quadrant 1, all the x values are positive, they're greater than 0, and all the y values are positive, they're also greater than 0. So quadrant 1, these are all positive on your x-axis, and your y-axis, they are all positive in quadrant 1. For quadrant 2, your x values here, you go here to the left, your x values are negative, but your y values up and down are positive, okay? So that's why we have negative x values and positive y values in quadrant 2. Quadrant 3 here, all your x values are negative, okay? And all your y values are also negative. All right, so there you go. These integers are less than 0. In quadrant 4, your x values are positive, but your y values are negative, okay? All right, so there we go. All right, so we have to understand what a polygon is. And this polygon we're going to be working closely with today to plot and graph on a coordinate plane. Now, a polygon is a closed plane figure which is two-dimensional with at least 3 straight sides. So here's some examples. These are polygons. So you have this rectangle, it's a polygon. This rhombus is a polygon. This hexagon is a polygon. Triangle is a polygon. A diamond is a polygon, and the pentagon is a polygon. What is not a polygon? These shapes over here, because these are either not closed figures or they don't have at least 3 straight sides. So this one has 1, 2, 3 sides or edges. This one has so this has 3 edges. Okay, the triangle has 3 edges. The rectangle has 4 edges. The rhombus has 4 edges. The hexagon has 4 edges, or sorry, six edges. The pentagon has 5 edges, and the diamond has 4 edges. All right. So again, these are polygons because they are closed figures. They're two-dimensional with at least 3 straight faces, or sorry, 3 straight edges. That's what we mean by sides, okay? Also, we want to also understand that these are also quadrilaterals, okay? So quadrilaterals. Now, quadrilateral, this is a polygon, by the way. Polygon, or this quadrilaterals are polygons with 4 sides. Now, for quadrilateral, quad stands for 4. Lateral stands for the word sides. So again, these are polygons that have 4 sides. All right, so there we go. And famous quadrilaterals are parallelograms, rectangles, rhombuses, squares, and trapezoids. All right, in our first example, we're going to draw a polygon in a coordinate plane. So let's read here. So vertices. The vertices of a quadrilateral are point A, -1 and 1, point B, 0 and 6, point C, 4 and 5, point D, 5 and -2. And we're going to draw this quadrilateral in a coordinate plane. Now remember, before we continue, we have vertices. Vertices, remember, they are 0-dimensional. So this would be a vertice, a point. It has no dimensions. Now, to a mathematician, to a physicist, dimensions, okay, so we're talking about dimensions. We're not talking about some alternate universe or anything like that. No, dimensions simply stands for directions, a location. Okay, so a location. So they are directions, they are a location, and we call those coordinates. Okay, coordinates, yeah. So this coordinate, you have ordered pairs. In an ordered pair here, you have your x value and your y value. Okay, so we call these ordered pairs. There you go. So there's your ordered pairs, x values and y values. So when we plot a vertice, we're talking about a point. Again, it's 0-dimensional because there's no height, there's no length, there's no width. Okay, so it's just a point. But when we have an edge, okay, some people call that a side, that's 1-dimensional. So for an example, if we plot another vertice here, or a vertex is singular, vertice is plural, and make a line segment, we have an edge. It's 1-dimensional. In this case, that would be like your y-axis, a height, or it could be side to side, horizontal, a length. But we do have a direction there, okay, up or down, left or right, and that's 1-dimensional. Now a face here is 2-dimensional because not only do you have a height, but you have a width, okay, and that makes a quadrilateral. It makes a polygon. And so this is what we're going to be plotting on the coordinate plane. All right, so I just want to touch base on that for real quick. So when we have these ordered pairs here, just remember that you have an x value, okay, and we also have a y value. All right, so let's plot the first one. Let's plot point A. We always start from the origin, the beginning, right here where your x value or your x-axis and your y-axis intersect, where they cross. So for the x value, we're going to go -1. So we go to the left one time. With the y value, we're going to go up +1. We're going to plot right there. So this is going to be point A. For point B, our x value is 0. And our y value is going to be +6. So here's 0. We don't go anywhere on the x-axis, but we go +6. And I'll plot that right there for point B. Point C, you have +4. So on the x-axis, I go +4. And on the y-axis, I go +5. And I'm going to plot that right here. This is point C. Point D, the x value is +5. Start from the origin, so I go +5 here. And then -2. So I go on the y value, I go down -2, and I plot right there, and that's point D. All right, so there you guys go. Now what we're gonna have to do next is we're gonna have to go ahead and connect them with line segments. So I'm gonna connect point A to point B. Connect these two vertices. You could use a ruler, you could use some sort of a straight edge. Then I'm going to connect these two vertices, point A to point D. Now remember, we're plotting polygons on the coordinate plane. All right, and then I'm going to go ahead and connect point C to point D, these two vertices. All right, oops. And then lastly, we're going to connect point B to point C with a line segment. All right, there you go. So in the middle, you have a polygon in the coordinate plane. So you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, so in the middle, you have this polygon. You have this here. All right, so what we're going to have to do is, that's basically it. So we just draw the quadrilateral in the coordinate plane. We've done that. So there you go. Now, I do encourage you guys to practice on IXL, especially with plotting points on the coordinate plane and also polygons. So there you go. All right, with this example, we're going to find distances between points. So we have two examples. First, we're going to find a distance between -3 and -5, and also +2 and -5. So we got to plot these 2 points. Then for B, we're going to find a distance between +3 and -2.5, and also +3 and -5. Now remember, ordered pairs. Okay, ordered pairs. You have your x value to the left of each ordered pair, and the y value to the right. Okay, and we use these. So here's your y values, your y-axis, okay, vertical number line, and your x-axis, your horizontal number line. All right, so I color coded it there. So first, let's plot the first one for A. So let's go to do that. So we're going to go start from your origin, the beginning, and then for this ordered pair, -3 and -5, we're going to go to the left, -1, -2, -3. Just like when you guys drive in a city, you stop at a stoplight. So that's kind of where we're at right now, is a stoplight. And then our next part, what we're going to do is we're going to go to a different location, -5. So that's going to be -5 on your y-axis. So negative numbers is down below the origin. So -1, -2, -3, -4, -5. We're going to plot there and label it. This is -3 and -5. Next, we're going to plot the next ordered pair, +2, -5. So on your x-axis, start from your origin, the beginning, the neutral number, 0, 0, +2 on your x-axis. So +1, +2, pause there, you're at a stoplight, and then -5. So we got to go below the origin. -1, -2, -3, -4, -5. Plot that and label it. This is +2 and -5. All right, so we want to know what is the distance between these 2 points. So normally what you would do, since they have the same y value and they're here located, if I were to count, we have, let me use a different color, 1, 2, 3, 4, 5. So the distance between -3 and -5, and also +2, -5, is we have 5 units. That's the distance, 5 units from each other. Another way you could do this is with absolute value, because since you have your x values, you have -3 and +2, they're different, but your y values are both -5. They're identical because they're in the same location, except for your x values. So your x value here is -3. I'm going to use absolute values, and I'm going to add that to +2, the absolute value of +2. So that's going to help me find a distance between these 2 points. The absolute value of -3 is 3. The absolute value of +2 is 2. And 3 plus 2 equals 5. So again, just like what we said, we have 5 units, the distance between this vertice and that vertice. Let's label this one point A and point B. Okay, so from point A to point B is 5 units across. All right, we're going to do the same thing for the second one. For this one, we're going to go +3 on your x-axis, and then -2.5. So here's -1, -2, -2.5. We're going to plot that there. This is 3 and -2.5. Label it. We'll call that one point C. And then for this ordered pair, +3, +1, +2, +3 for your x value, and -5 for your y value. -1, -2, -3, -4, -5. So this one will be point D. Okay, kind of crossing there. But again, we want to know the distance from point C to point D. we have 1, 2.5. So that distance is going to be 2.5 units from point C to point D. All right, 2.5 units apart. So again, because you have the same x values, we're going to look at the y values. So the y value here is -2.5. So I want to find the absolute value of that and add that to the absolute value of -5. So the absolute value of 2.5 or -2.5 is going to be +2.5, and the absolute value of -5 is 5. 5 plus 2.5 is going to be let's see here. Actually, a minus. I'm sorry, a minus. I made a mistake, so that's minus. This is actually takeaway. Okay, so we just got to subtract. So 2.5 take away 5 is going to be 2.5. All right, because it has 2.5 spaces from there. All right, lastly, we're going to model real life. So I'm going to read to you guys this paragraph. So an archaeologist divides an area using a coordinate plane in which the coordinates are measured in meters. So it's measured in meters. The vertices of a secret chamber are -8 and +10, +4 and 10, +4 and 2, and -8 and 2. So we want to find a perimeter and the area of the secret chamber. Okay, so let's go ahead and plot these. So -8 and 10. So here is the origin. -8 is here, and I'm +10. So I go up to +10. Plot that point there. I'll call that point A. Cross it out. And then start from origin again. We'll call this one point B. So on your X value, we're going to go +4 and then go up +10. Boom, right here. So this is point B. Point C, start from origin again, is going to be +4 and +2. Plot there, that's point C. Point D is going to be -8 and +2. Call that point D. All right, so now we found that secret chamber. Now we're going to go ahead and connect these with line segments. Point B to C, point A to B, point D to C. And there, my friends, you have this polygon. This polygon is also a quadrilateral. It is the shape of a rectangle. So we are asked to find the area, and this is the area of a square, so that's going to be area equals base times height, and also the perimeter. To find a perimeter, it's going to be side 1 plus side 2 plus side 3 plus side 4. All right, so here's my formulas. Now, I don't know the height of this quadrilateral, this rectangle, but I can count. So we have 1 unit, 2, 3, 4. So from here to here is 4 meters. 4 meters tall. Now we got to get the base of it. So we have 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units. So we have 6 units or 6 meters. Okay, that's the distance from point D to point C. So we have the base measurement and the height. So we plug those in now. To find the area here, we multiply base times height. So the base here is 6 meters times my height, 4 meters. Okay, area equals. And then 6 times 4 equals 24. So this is be 24 meters squared. That's the area. 24 meters squared is the area. And the area is all the space that is inside the polygon. All the space that's inside this rectangle, this quadrilateral. For the perimeter, I had to add all these sides up. So this is like, let's call this one side 1. This down here is going to be side 2, side 3, and side 4. Okay, so all we're going to do is add 4 plus 6 plus 4 plus 6. All right, so think of like a fence, like a yard. So we want to find the perimeter around the yard, all right, in this case. So again, right here, the perimeter of side 1 equals 4 meters, plus side 2, 6 meters, plus side 3, 4 meters, plus side 4, 6 meters. All right, to find the perimeter. So P equals, perimeter equals 6 plus 6 equals 12 meters, plus 4 plus 4 equals 8 meters. Okay, now 12 plus 8 equals 20. So the perimeter equals 20 meters around that whole rectangle. All right, now notice I didn't square it. I didn't square it because I'm adding. I only square when I multiply. All right, so there you guys go. So the perimeter equals 20 meters around the whole rectangle, and the area, the space inside, is going to be an area of 24 meters squared. All right, so that was a quick lesson, pretty straightforward. Now, by now, you should be able to plot and graph polygons inside the coordinate plane. You should be able to draw polygons in the coordinate plane and find the distances between the points or the vertices in the coordinate plane with the same x coordinates or the same y coordinates. You should also be able to find horizontal and vertical side lengths of a polygon, just like what we did here. All we did was count these units and then notice that it's measured in meters. Okay. And lastly, you should be able to draw polygons in a coordinate plane to solve real life problems. So there's really nothing to it, ladies and gents. I do encourage you guys to, change your mindset, change your thinking. Don't dread math, but rather have fun with it. Have fun with math. And I promise you, you'll be, once you change that mindset, you're going to have a lot of fun with it. All right. Don't forget to ask questions, ask your teachers for help, and get those assignments in. Get them in and, and change your grade. It's not too late.